All right. Good morning, good afternoon, good evening, wherever you may be. I hope everybody had a great weekend out there. We got another couple of weeks to go. I think we got 3 weeks left. Today we're going to talk about weather forecast maps. Just remember, hey, while you're in here, go ahead and say hi down in the comment section. It counts as your attendance for today. And go ahead and like the video and subscribe to the channel. But as I said, so today we're going to talk about Earth system. So last time we talked about forecasting and our need for knowledge of the weather in the future, because frankly, we all know what it is right now. We just go open a window and look at it, but we always want to know what's going to happen to us in the future. Then we're going to talk about what this all looks like on a map. So we're going to give you a bunch of different examples of current weather maps. And actually, the maps we're going to use today are actually the current weather maps for today. So here's what is a current prediction map from NOAA, National Oceanic. That's right there, NOAA, the National Oceanographic and Atmospheric Administration. It's a government service, providing us weather information. So if you look at this, it's like, well, some of the things that are on here, you're like, oh, wait a minute, I see an L, I see an H. I recognize those. We've talked about kind of stuff. So an L is a low pressure system, and H is a high pressure system. And there's that blue, the blue line with the triangles on it. Guess what? That's a cold front. We know what that is. Over here, we see a little red line with a round thing on it. That's a warm front. Know what that is. Oh, and we see this down here where it's alternating blue and red. Well, that's a stationary front. Well, I've seen that before. And right there, that little piece right there, you can see that's purple. There's another one right there. And so purple ones we know are occluded fronts. Talked about those a couple days ago. So there's a bunch of information on this map that we're kind of familiar with. But there's some things that we got like, hey, wait a minute, don't know what that is. But we do have a key down here. So this area, so we'll see this area in green right here is precipitation, rain, thunderstorms. The blue says mixed precipitation, which guess what? Yes, that means some sort of frozen stuff coming out of the sky. I've actually got video from my mother's house of it snowing Saturday night. She got a couple inches. Didn't last long because the temperatures got up in the 60s the other day. But it snowed, and it's still scheduled to snow some more up in here today and out here in the upper west. And then there's this area right here. It says critical fire weather, so it's going to be real hot and dry. And then an area right there along that piece of that stationary front where that severe thunderstorms are possible. Now again, possible, I start talking about projections. So they're making a projection. What's going to happen right here? Excuse me. Then we have one more thing on here that's kind of new to us, and that's this orange dash line right here. That's called a trough. So the orange dash lines indicate a trough. A trough is an area of lower pressure in an air mass. So remember, between fronts, this front, this cold front here, and then this cold front here. So here's an air mass, here's an air mass, and then here's an air mass. Because remember, between fronts, these are different air masses. So the front is the leading edge of a definitively different air mass. Wait a minute, you're like, wait, that's a cold front, and that's a cold front. So how can you have a cold front and a cold front? Well, this mass up here is definitely colder than this mass right here, even though they're both cool. One just happens to be colder than the other. Well, doesn't that mean that this should be a warm front going this way? Nope, because that means this air is cooler than this air. So the warm front's like over here somewhere where this warmer group of air is, but then it's cool and then it's cold, giving us two cold fronts. Need to know. So we have our pressure, and you see there's a lot of L's on the map, and then H's, H, L, L. So it's like L, L. Wow, it's seems to be a lot of low pressure systems. Um, and this is unusual. Typically, you don't see so many low pressure, spots of low pressure, but it's not unheard of. So there's a trough going that way, and there's a little bit of a trough running down through here. So again, the frontal line is here. There's high pressure here, there's low pressure here, and then a front air. So this air mass has got all kinds of things going on in it right in here. So the air mass, remember, air mass is defined by air of typically of the same temperature, but it's obviously got a high pressure chunk of it, a low pressure chunk of it, some troughs going on in there. So this is a very unhappy air mass. Let's say that. Go down here. So the L's low pressure, H is the number high pressure. On the fronts, the trough, rain, woo. And then we're going to get down to what we call the surface analysis. So this is, the overall weather prediction, but then we get down here and this thing is called a surface analysis. It actually says it right down here, 0900 Zulu. Now, Zulu time is literally the time along the meridian over in Greenwich, England. So here in North Carolina, we are -5 from Zulu time, depending on, I can't remember if it's -5, just -5 for all intents and purposes. So at 0900 Zulu, which would have been 0400, 4 a.m. for us, that this was put out. But it wasn't issued until 1112 Zulu, which is -5, 6 a.m. 6:12 a.m. is when this was actually issued. So the analysis was from 4 a.m. at 6:12 a.m. it was issued. So now you'll see some of the same things. All right, so there's a double low and a high up here over Western New York. We go back up here. Well, they just got it as a one large low over Western New York. Well, at the surface, you can see there's a low here, and then a high here. And you're like, hey, wait a minute. How in the world can you have all those things right there? And again, so this is just generally what's the readings of the surface. So one of the things that gets added in here, so you still have your orange trough lines, trough. You have your frontal lines. You have your H's and your L's, high and low pressure systems. Obviously your fronts, cold front, stationary front, occluded front right there, purple. There's a purple chunk right there, occluded front. So you still have those things. And you'll notice that this one is dated 4:33 a.m. Eastern Daylight Time. So that would have been, about the same, but it was issued at that point, whereas the other one's issued at 6. So this is a couple hours. So you can see that, this stationary front, not that stationary because that low is drifted all the way down to Cuba, and here you can see the difference in the maps. So that low is halfway between the end of the Yucatan and the end of Cuba, and over here it's practically sitting on the end of Cuba now. Well, it actually is sitting on the end of Cuba. You see the line of Cuba right there. So it's moved a little bit in a couple hours difference in the time the maps were compiled. But now the one thing that this one adds to it, so is the long lines of the numbers on. These are called isobar lines. They're lines on a map connecting points having the same atmospheric pressure at a given time on average, or an average over a given period. The numbers along the lines are the pressure readings in millibars. Bold, darker maroon numbers are the highest or lowest pressure in areas. So we're gonna look at this thing. We see there's a line right there, and it's got 1020 on it. That's 1,020 millibars of atmospheric pressure. And this line kind of curves down here, creaks up, down, up, curves back this way, around. It's like, holy cow. And that one's 1,016. The next one coming this way is 1,012. Comes down here, around here, wraps this way, over here, over here, over here, up, bends, and it's like, holy cow. It's like, how do you follow that? I mean, it's pretty hard. But those lines are derived from pressures readings taken at the surface. So they just connect surface readings with a line. So all the lines, all the surface readings that read, and here's one right here that says 1032. Just connect all the line, the pressures readings at the surface that connect, that say 1032, they make a line out of it. 1036, get down here, 1024. Actually, I think 1024 is this line. So if that's 1032, that's 1024, that's 8. So this should be like 1028 on this line right here. It just doesn't have it written anywhere. But then you have the high right here, and you got that right there. It says 1031. So that high pressure, that little H is given to the highest pressure little spot in the given area. You see this fold, this line, it kind of, almost circles it, just like this one over here, because you have a low pressure, and it's 1,007 millibars. Then you have a line right, all the way around it of 1,008. So that's the center. That's an L because it's the center of an area of low pressure. And it's right on that little trough line. Look at that. See that trough line right there? There's these trough line. This trough line comes down. Remember, trough is an area of low pressure. That's not a front. It's just an area of low pressure. And there's these little individual centers of low pressure in the middle of this air mass here. Because remember, here's a front. Here's a stationary front. So this is one air mass. So the temperature is basically the same across here. Man, is it disturbed. Then you got an area right here. See all the isobar lines kind of circling this thing? 1,017 millibars of pressure right there in the middle. 1,016, 1,008, 1,012. And then right, very close to it's an area of low pressure, 1,004 millibars. So there's a lot of things going on here in that particular air mass. A lot of interesting things. So now, weather in the United States always travels in what direction? From the west to the east. So it's always going this way for the most part. I mean, it can go down, it can come up, but it's for the general area, it's moving this way. So when we see, things like this, so it's like, all right, so which way is this moving? So again, remember the arrows on the frontal lines tell you which way that front is moving. It's just the low, or low, everything travels this direction around lows, counterclockwise. Now a high, things travel clockwise around. Change that color, right? See these high pressure systems, air flows around this way. Clockwise around the highs. Counterclockwise around the lows. So since this low has got these fronts kind of attached to it, these fronts are moving like that. This one's going this way. Then you have this occluded front here, which is, remember, where it's basically a cold front catches up with a warm front. And it becomes stationary right there. This cold front, but see, here's the thing. We've got a low pressure system that, the air should be coming this way around, right? Then we got a high pressure system, which the air should be going this way around. I mean, you have stuff like that. It's like, holy cow, how in the world do we figure this out? And the answer is this off so I don't leave that stuff just there. Turn that off. So now the answer is, it's like, all right, we have to use computer programs. So these maps give us what's going on now, and how do we use this to forecast? So again, we were on the computers, and the models we created based on our prior knowledge of what has happened. So we put all this data in, and then we actually see what happens. And then we plug that in, and we see what happens some more. And you take all this data and you plug it in the computer, and then you build the model and saying, all right, so based on these things, this is what you make important when you predict. So then now the weather people take that information, what's going on right now, what has just happened, and they predict what's going to happen in the future. And we use computer probabilities to map out what's going to happen in the picture. So we're going to jump over here again, and we're still in the National Weather Service. So now, here's the Monday at 1200 Zulu, which is, again, the last one was 900 Zulu. This is the 1200. So this is 3 hours, 3 hours later. And so we've, this cold front's moved all the way down to here, passed through Carolina. So guess what? We've got a cold front coming through sometime today. This cold front's come from up here. And now it's crossing across upper New York, Iowa, Indiana, banging into western Pennsylvania there. So then obviously green, just like on a radar, is rain, potential rain, heavier green, or higher potential rain. These hashed areas like this, here's all your keys over here for for this. So the darker red thunderstorms are maroon, and lighter red are chances of thunderstorms. See, we see some dark maroon down in here. That looks like outlining that edge. This hash right here, probably with lighter maroon. Storms, and then this purple. There's purple right there. Mix of precipitation. Snow, blue. So you can see all the different, things that they're projecting. So again, this is only 3 hours from now at 1200 Zulu. So the last one was 0900. This is 1200. So this is 3 hours later. So now we're going to look at. Now we're at the next one, Tuesday morning, tomorrow. Cold front that was in the Carolinas is now well off the coast. Here comes this other cold front down here. This low, everything's kind of rotating around. It's kind of shifted over here to New England, just north of Massachusetts, up over Maine. Now we have a warm front that's kind of developed. So back this up and look at, here. This is a stationary front, and then this air mass here has become a warmer air mass. It's warmed up down here in the southwest, and now that frontal line has become a warm front. So as a warm front pushes into, where cooler air was, remember, it overrides it, goes over the top, the warm front climbs over the top of the cooler air because the warmer air is less dense, and then forms that wedge. And along that wedge is where you get precipitation, which, guess what? They're forecasting precipitation along that line. Again, we have a cold front here, counterclockwise rotation, around low pressure system. We have a counterclockwise rotation around a low pressure system, so it'll be interesting to see. But again, look at the air, look at the bumps on the warm front, so you know which direction it's moving. Then you have this another low up here, warm air moving this way, cold air moving that way. You have this big low out here in the Pacific Ocean. Just look at that occluded front to it. And now it's that cold front's moving into the coast. And again, cold front pushing warmer air in front of it. Warmer air rises, gives you that chance of storms right there. So now we're looking at first thing, basically right after midnight, Zulu. So basically 5 a.m. on Tuesday. Fronts progressed. And we're looking at 0600 Zulu Tuesday, which is -5 would be just after midnight here. So that last one, midnight Zulu, basically, which is that's tonight for us. 0600 Zulu by 1 a.m. It's warm front. Again, this air mass here is kind of sinking because now this cold mass is pushing it. So it's kind of squeezing it south, is what it looks like. And then we have the warm front, it's kind of moving that direction. And this cold front, wow, is a serious cold front. Look at the length of that cold front. And this little chunk here is kind of petered out. It's kind of petering. This cold air mass behind this front right here is kind of petering out a little bit. It's not as given, but we notice our isobar lines here, 1020, 1024, 1026. So this high pressure system is kind of building in over Kentucky. Remember, high pressure systems, clockwise rotation. So this thing's wanting the air to go this way. It's low, remember, counterclockwise around the low. A couple hours later, all right, that front moves off the map over here. Now, is it gone? No, it probably continues on around up here just like it was. This low's moved off the coast. Now we're dealing with this cold air mass coming in. Remember, this is cool air and this is cooler air. That's why we had all that snow up there in the north over the previous couple of days. But now look at what's going on up in here. So this low has got stuff rotating around it, so it's kind of kicking that front. Now this becomes stationary right here because guess what? There's a low here, and this stuff wants to go this way, but this one's going no, I want it to go that way. So they're kind of fighting right here in the middle of this, between the two, and that it kind of strands that front right there between the two. Wait for those two air masses, actually, the two pressure systems to move themselves. But you got warmer air, and warmer air tends to be more moist, right? Cooler air up here with this high, and as that warmer air comes through, guess what? You get all your storms and stuff. So now that low pressure system is moved off to up in the North Atlantic. Cold front starts coming through. High pressure slides down from the Midwest, sitting right over eastern Kentucky. So our weather, at that point, not a whole lot going on, just because we have high pressure in the area. But here comes the disturbed area in front of this warm front. And this is the last projection on the short range projection. So the high that was over us moves up. This one kind of zigs that way now. Now some of this disturbed weather in front of this cool front or warm front starts getting close enough to us that we may get affected by it in a couple days. But again, you can see how those things are moving. We're going to go backwards now. Backwards, 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 backwards. You watch those fronts move over here, right over here. Forward, 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 forward. So that's why we have, that's how we read the weather map and the information that's on those weather maps. We take the surface analysis, what's going on right now, we plug it into our computer systems with our models, and based on what's happened in the past, we make projections based on the models we've built based on what's happened in the past. And we use that to predict the weather in the future. And we do short range and then we do long range. So now, so it is days 1/2 to 3 to 7, continental United States. So day 3, full color. Let's just go look at this. So now these things start getting a little more generic. They're not nearly as because this is day 4. This is after the last map we looked at that was 3 days out. So they get a little more generic when we look at the further out we go, because again, the further out you go, the more it's just this is kind of probable. This is kind of probable. This is what we think is going to happen. Day 5, high pressure builds back in over the Carolinas. Now I got a cold front. So here's that funky, crazy mass of air. Still just kind of not really deciding on what to do down here. Now you see this thing right here. This is new to us. This little looks like a warm front line because it's a line with circles, but it's got orange in it. That's a dry line, and it basically says that even though these there's no frontal boundary here, so it's effectively the same air mass. There is a line of definitively different moisture content between here and here. So that's what they call that right there, the dry line. So there's way more moisture over here than over here. Day 6, that line is still in the same spot. That low is about the same spot. Now we got a stationary front up here. The high over the Carolinas is still kind of standard, wandering downwards. Day 7, that high is still over the Carolinas. Hasn't gone anywhere. Now again, here, front, still kind of crazy looking. Stationary front. Warm front up here, stationary out this way. So since it's low, since it's rotating this way, it's dragging this air mass is going this way. But it gets to the point where between this high and this high, that this air mass can't push that high from here to here. And then, so things are, weather's complicated. It's not just, oh yeah, this happens, then this happens, then this happens. And then, we're 6 days out. So we're really started getting into the just wild guess stage. 7 days out. Well, that was 7 days out. This is now day 3. So this is way out there. Whew. Cannot get rid of the yawns today. All right. Hope this wasn't, again, so you need to remember, what's an H, what's an L, high and low pressure, the frontals, how the fronts move, which direction the weather's moving. Weather always moves from the west to the east, right? From the west to the east. That's how weather always moves. So you guys just have to remember that. If it's a red line, it's a warm front. If it's a blue line, it's a cold front. And if it's a red and blue line, it's a stationary front. Purple is occluded. The orange lines with dashes on them are troughs, are just areas of low pressure inside of a air mass. Where air masses are masses, basically they typically have the same air temperature, and then your long lines on this particular map, the long lines, the isobar lines are green, but in other cases, sometimes they can be, orange, or maroon, depending on which map you're looking at. So, but when you see these long curved lines, just remember those long curved lines and circular lines like that are isobars, which are the connect the dot temperature line, pressure lines. And their pressure are given on maps in the United States as millibars: 1020, 1016, 1008, 1012, 1012, 1016. That's pressure, millibars pressure. So if you have any questions or anything else, you need to get in contact with me, 704-363-9034. Hope you guys stay safe. Remember, 6 feet apart, social distancing. Even though we're kind of opening things back up here in North Carolina, you still have to maintain your social distancing between you and people you haven't been quarantined with. You get any closer to that, you start talking, this is where the numbers are going to start increasing in any given area that's kind of, increased the amount of circulation of people. Just remember, most people that have the virus don't have any signs of it and won't ever have any signs of it, but they still have the virus. That's why you need to stay 10 to 12, 6 feet away and wear a mask. Somebody sneezes, that can send enough virus particles out of their mouth at 200 miles an hour, so those particles can get hundreds of feet away on air currents. And if you just happen to wander through, I mean, it can take anywhere from, based on current knowledge, about 1,000 of those virus particles get into you, and you catch it. And again, you may be one of the people that just wanders around and has it and has no symptoms. Then you may pass it to your mom. You may pass it to your grandparents or somebody that they run into. And that person may be the person that is susceptible to actually catch COVID-19. So it's not about, well, I feel fine. It looks like the people around feel fine. It's when you run into somebody that has something else wrong with them. And that's what the issue is. 6 feet. Wear a mask when you're outside with any, in any kind of place where you're going to run into people. If you're riding your bike by yourself, you don't need a mask. You're riding in a group, hanging out, actively looking at a group of friends, you need to wear a mask. All right, stay safe. Catch you guys later.